October 2016, Baltimore Harbor, the USS Zumwalt DDG-1000, the most advanced warship ever built, breaks down during its maiden voyage. The Navy's flagship destroyer, stealth technology, revolutionary weapons, the future of naval warfare. Dead in the water, towed back to port. Cost to build, $4.4 billion. That's more than an aircraft carrier. And it gets worse. The Zumwalt's main guns, the advanced gun system designed specifically for this ship, fire ammunition that costs $800,000 per round. The Navy calls it too expensive and cancels the ammunition program. Now the Zumwalt has two massive gun turrets that don't have ammunition, 6,000 tons of warship, two giant paperweights mounted on the bow. This is the story of how the U.S. Navy spent $22 billion on 3 destroyers that can't perform their original mission. How the most expensive surface combatant in history became a symbol of everything wrong with military procurement. Let's break down the Zumwalt disaster. The Zumwalt class was born from ambition. In the 1990s, the Navy envisioned a next-generation surface combatant to replace aging cruisers and destroyers. The requirements were aggressive. Stealth design to minimize radar signature, advanced sensors, network-centric warfare capability, land attack mission focused on supporting Marines with naval gunfire. The centerpiece, 2 advanced gun systems, 155mm guns capable of firing rocket-assisted projectiles 83 miles inland, precision strike, rapid fire, overwhelming firepower. The Navy wanted 32 ships, a whole new class of destroyers to dominate the 21st century. What they got? 3 ships, broken guns, mission confusion. A program so over budget and behind schedule, it became a case study in acquisition failure. Here's where it started going wrong. The Zumwalt was designed in the late 1990s for a post-Cold War world. The Soviet Union was gone. No peer naval threat existed. The Navy shifted focus from blue water combat to littoral operations, shore bombardment, supporting ground forces. Hence the advanced gun system, long-range naval gunfire to support Marines assaulting beaches. Then 9/11 happened. The wars in Iraq and Afghanistan dominated defense spending. Naval gunfire support became irrelevant. Air power handled ground support. The mission Zumwalt was designed for evaporated. But the program was already too far along to cancel. Contracts signed, shipyards committed, political pressure from Congress to keep jobs. So the Navy kept building a ship designed for a mission that no longer existed. Problem 2, technology risk. The Zumwalt incorporated cutting-edge systems that had never been tested at scale. Tumble-home hull design for stealth, integrated power system, advanced automation to reduce crew size. Each innovation added complexity. Each complexity added cost. Each cost overrun reduced the total number of ships the Navy could afford. The original plan, 32 ships at $1.4 billion each. As technology challenges emerged, costs exploded. The Navy cut the order to 24 ships, then 12, then 7, finally 3. Each cut made the remaining ships more expensive because development costs spread over fewer hulls. By the time the first Zumwalt launched, the per-ship cost hit $4.4 billion, 3 times the cost of an Arleigh Burke destroyer, nearly as expensive as a Gerald R. Ford supercarrier. For context, an aircraft carrier carries 90 aircraft, 5,000 crew, projects power globally. The Zumwalt carries 80 missiles, 140 crew, and guns without ammunition. The math doesn't work. Let's talk about those guns. The advanced gun system. The reason Zumwalt exists. 2 155mm naval rifles, fully automated, designed to fire long-range land attack projectile rounds, LRLAP, GPS-guided, rocket-assisted, 83-mile range. On paper, revolutionary. A destroyer could sit 80 miles offshore and rain precision fire on enemy positions. No aircraft needed, no risk to pilots. In reality, disaster. Each LRL-AP round cost $800,000 to $1 million for a single artillery shell. The Navy planned to order tens of thousands of rounds. At those volumes, cost per round would drop to maybe $50,000. Still expensive, but justifiable. Except the Navy only built 3 Zumwalt destroyers instead of 32. Smaller order, higher per unit cost. Ammunition costs never came down. At $800,000 per round, the Navy could fire a Tomahawk cruise missile for less money. Tomahawks have 1,000-mile range, not 83 miles. They carry bigger warheads. They're more flexible. Why fire an $800,000 artillery shell when a Tomahawk costs $1.5 million and does more? The Navy couldn't justify it. In 2016, they canceled the LRL-AP program. Now the Zumwalt has 2 advanced gun systems with 0 ammunition. The guns are so specialized, no other round fits. They're permanently useless. The Navy is now spending millions to remove the guns and replace them with hypersonic missile launchers, ripping out the primary weapons system the ship was designed around. This is what failure looks like. The hull design, tumble home. Traditional warships have flared hulls. The sides angle outward as you go up. This improves stability and increases deck space. Zumwalt has an inverted tumble-home hull. The sides angle inward. This reduces radar cross-section, improving stealth. It also makes the ship less stable in rough seas. The Zumwalt rolls more than conventional destroyers. Crew reports say it's uncomfortable in heavy weather. And here's the kicker. The stealth advantages are marginal in modern naval warfare. Stealth works against radar, but modern anti-ship missiles use multiple guidance methods. Infrared, electro-optical, home on jam. Even if radar can't see Zumwalt perfectly, other sensors can. And once you're detected, stealth doesn't help. A missile doesn't care if your radar cross-section is small. If it has a lock, it's coming. The Navy sacrificed stability and seaworthiness for stealth that provides limited tactical advantage. The integrated power system, another technological marvel that became a headache. Traditional warships have separate systems for propulsion and electrical power. Engines drive the propellers. Generators provide electricity for weapons and sensors. Zumwalt uses an integrated system. 2 Rolls-Royce gas turbines generate electricity. That electricity powers everything. Propulsion motors, weapons, sensors. The entire ship runs on electric power. Advantages: flexibility. You can redirect power from propulsion to weapons, or vice versa. Future energy weapons like lasers benefit from massive electrical generation. Disadvantages: complexity, vulnerability. If the power system fails, the entire ship goes dark. Propulsion stops. Weapons offline. Dead in the water. Which is exactly what happened on Zumwalt's maiden voyage in 2016. A software glitch in the power management system caused a failure. The ship lost propulsion in the Panama Canal. Had to be towed. Subsequent breakdowns occurred in 2017 and 2018. Each time, power system failures. The technology works. Eventually, after years of debugging and software patches. But it introduced risk and unreliability that conventional systems don't have. Automation and crew reduction. The Zumwalt has a crew of 140. An Arleigh Burke destroyer carries 300 crew. The Navy wanted automation to reduce manpower costs. Fewer sailors means lower operating expenses over the ship's lifetime. So Zumwalt is heavily automated. Damage control, engineering, even food service uses automated systems. Great in peacetime, terrible in combat. When things break, you need people to fix them. The Zumwalt has fewer people. Damage control teams are smaller. Repair capacity is limited. In a high-intensity conflict where ships take damage, crew size matters. More hands, more redundancy, more ability to recover from hits. The Zumwalt sacrificed wartime resilience for peacetime cost savings. And the cost savings didn't materialize. Because the ship is so complex, maintenance is expensive. Specialized contractors. Proprietary systems. The money saved on crew salaries gets spent on maintenance contracts. Mission confusion. Originally, land attack destroyer for naval gunfire support. After guns failed, multi-mission destroyer for air defense and anti-surface warfare. Current mission, technology demonstrator and test bed for hypersonic missiles. The Zumwalt has had 3 different primary missions, none of which it performs better than existing platforms. Air defense, the Arleigh Burke is better. More VLSLs, proven Aegis system. Anti-surface warfare, again the Arleigh Burke is proven, reliable, cheaper. Hypersonic missile test bed, you don't need a $4.4 billion destroyer for that. You could modify an existing ship for a fraction of the cost. The Zumwalt doesn't excel at anything. It's a jack of all trades, master of none, except it costs 3 times more than a ship that is actually a master. Stealth features. The Zumwalt's angular design minimizes radar reflection. Composite materials absorb radar waves. The entire ship is designed around stealth. It works. The Zumwalt has a radar cross-section comparable to a small fishing boat despite being 15,000 tons. But stealth in naval warfare has limited utility. Against aircraft and anti-ship missiles, stealth helps. You get detected later. Maybe you survive the first wave of attacks. But modern naval doctrine relies on networked sensors, satellites, drones, maritime patrol aircraft, submarines. Even if your destroyer is stealthy, someone in the network will find you. Once found, your stealth doesn't matter. The missiles are already launched. And stealth provides zero protection against submarines. Sonar doesn't care about radar cross-section. The Navy spent billions on stealth technology that provides marginal advantages in real combat scenarios. Compare this to the Arleigh Burke. Flight 3 Arleigh Burke destroyers cost $1.9 billion, less than half the price of a Zumwalt. The Burke carries 96 VLS cells. The Zumwalt carries 80. The Burke has Aegis combat system, the most proven air defense system in the world. Combat tested, reliable. The Zumwalt has a newer radar system that's still working out bugs. The Burke has a crew of 300, more people for damage control, maintenance, operations. The Zumwalt has 140 crew and relies on automation that has repeatedly failed. The Burke has a conventional hull design, stable, seaworthy, proven. The Zumwalt has a tumble-home hull that rolls more and provides marginal stealth benefits. The Burke is in production. The Navy builds 2 per year. The Zumwalt production line is closed. 3 ships. That's it. For the cost of 3 Zumwalts, $13.2 billion, the Navy could have built 7 Arleigh Burkes, 7 proven, reliable, combat-capable destroyers. Instead, they got 3 experimental ships with broken guns and an identity crisis. Political pressure kept the program alive. Defense contracts mean jobs. Congressional districts with shipyards fight to keep programs funded, even failed programs. Bath Iron Works in Maine builds the Zumwalt. Thousands of jobs. Senators and representatives from Maine lobbied hard to keep the program going. Even as costs exploded, even as the mission changed, even as the Navy admitted the ship didn't meet requirements, Congress kept funding it. This is how military procurement fails. Technical challenges combine with political pressure. Costs spiral. Capability diminishes. But the program survives because canceling it means job losses and angry voters. The result, the Navy gets ships it doesn't want, performing missions that don't exist, at costs that cripple the budget. Lessons learned. The Zumwalt represents everything wrong with ambitious defense programs. Too much new technology at once. Instead of incremental improvements, the Navy tried to revolutionize everything. Hull design, propulsion, weapons, automation. All untested, all risky. When one system fails, it cascades. The guns failed, invalidating the primary mission. The power system failed, causing operational problems. The costs exploded, reducing the fleet size and making each ship unaffordable. Mission creep and changing requirements. The Zumwalt was designed for one mission. That mission became irrelevant. Rather than cancel the program, the Navy tried to repurpose the ship. It's now a misfit doing missions it wasn't designed for. Lack of competition and oversight. Bath Iron Works had the contract. No competition. No pressure to control costs. The Navy had invested so much, canceling felt impossible. Sunk cost fallacy at a national scale. Optimistic cost estimates. Every defense program underestimates costs. The Zumwalt was supposed to be $1.4 billion per ship. It ended up $4.4 billion, triple the estimate. If the Navy had known the true cost up front, they never would have approved the program. Current status. 3 Zumwalt-class destroyers exist: USS Zumwalt, DDG-1000, USS Michael Mansour, DDG-1001, USS Lyndon B. Johnson, DDG-1002. All 3 are operational. Technically, they patrol, they conduct training exercises, they show the flag, but they don't perform the mission they were designed for, because that mission no longer exists and the weapons don't work. The Navy is now modifying them for hypersonic missiles, conventional prompt strike weapons, turn them into missile trucks. It's a reasonable use, but it's a consolation prize. These ships were supposed to revolutionize naval warfare. Now they're expensive platforms for missiles that could be launched from cheaper ships. Total program cost, $22.5 billion for 3 ships. For comparison, the Navy's newest aircraft carrier, USS Gerald R. Ford, cost $13 billion. The Ford carries 90 aircraft, projects power globally, can win wars. 3 Zumwalts carry 240 missiles total, limited mission capability, broken guns. Which is the better investment? The answer is obvious. The Zumwalt is a cautionary tale. Ambition without realism, technology without testing, political interference without accountability. It's a 15,000-ton monument to procurement failure. The U.S. Navy wanted the future. What they got was an expensive mistake that will sail for 30 years as a reminder of how not to build warships. Future programs learned from Zumwalt. The Constellation-class frigate uses a proven foreign design, less risk, lower cost, faster delivery. The DDGX next-generation destroyer focuses on incremental improvements to existing Arleigh Burke technology rather than revolutionary leaps. The Navy learned the hard way, but the lesson cost $22 billion. 3 ships that don't work as intended, guns without ammunition, missions without purpose. The Zumwalt is the most expensive, most advanced, least effective destroyer in the U.S. Navy, and there's no going back. The shipyard that built them has moved on. The technology is outdated. The design is a dead end. 3 ships, that's all there will ever be. A billion-dollar mistake, sailing the oceans, a testament to ambition, hubris, and failure. Welcome to the USS Zumwalt, the future that never was. The human cost of the Zumwalt disaster extends beyond dollars. The Navy had a budget. Every dollar spent on Zumwalt was a dollar not spent on proven platforms. While Bath Iron Works built 3 experimental destroyers, the fleet aged. Ticonderoga-class cruisers, the backbone of carrier air defense, reached 30 years old. Maintenance was deferred. Upgrades postponed. Money went to Zumwalt instead. Oliver Hazard Perry-class frigates retired without replacement. The Navy had no small surface combatants. Gaps in coverage. Missions left unfilled. All because $22 billion went to 3 ships that don't work as designed. Opportunity cost, the silent killer of military readiness. Those $22 billion could have bought 11 Arleigh Burke destroyers, 44 Constellation-class frigates, 6 Virginia-class submarines, 2 Ford-class aircraft carriers with change left over. Any of these options would have provided more combat capability than 3 Zumwalts. But hindsight is perfect, and canceling a program is politically impossible once billions are spent. So the Navy kept building, kept hoping, kept justifying, and ended up with 3 ships nobody wanted. The international implications: China watched the Zumwalt program closely. They learned what not to do. When China designed the Type 055 destroyer, they took a different approach. Incremental technology, proven systems, build first, perfect later. The Type 055 uses variations of existing Chinese radars, missiles, and propulsion. Nothing revolutionary, nothing untested. Result: 8 ships in service, more under construction, all operational, all effective. Total program cost, estimated $7 billion for 8 ships, less than 1 Zumwalt per ship. China built a larger fleet of more capable destroyers for less money by avoiding the mistakes America made with Zumwalt. Russia did the same. The Admiral Gorshkov-class frigate uses proven technology, conventional design, no experimentation. 12 ships planned, 7 already in service. Each one costs about $500 million. For the price of 1 Zumwalt, Russia built 9 frigates. The lesson is clear. Revolutionary designs sound impressive. Incremental improvements win wars. Allies questioned American naval competence. When the Zumwalt broke down on its maiden voyage, international media covered it extensively. The most advanced destroyer in the world, dead in the water. U.S. naval credibility suffered. If America can't build a working destroyer, how reliable are their security guarantees? Japan, South Korea, Australia all depend on U.S. naval power to counter China. The Zumwalt failure raised doubts. It's a soft power loss, difficult to quantify, but real. The technical deep dive. Let's examine specific failures in detail because understanding how things broke reveals deeper procurement problems. The advanced gun system. Why did it fail? The AGS fires a specialized 155mm long-range land attack projectile. This isn't a standard artillery shell. It's a guided rocket-propelled projectile with GPS navigation and course correction fins. Development started in the 1990s. Lockheed Martin designed it. The concept was sound. A ship could provide precision fire support from over the horizon. No risk to the vessel. No aircraft needed. Testing showed promise. The technology worked. Accuracy was good. But nobody calculated the true cost until production started. Each LRLAP required GPS guidance system, $200,000. Rocket motor, $150,000. Precision machined components, $300,000. Soundboard, quality control and testing, $150,000. Total, $800,000 to $1 million per round. The original estimate, $35,000 per round. How did the estimate miss by a factor of 25? Optimism. The Navy assumed economies of scale. If they ordered 50,000 rounds, costs would drop dramatically. But the Navy only built 3 Zumwalts. 3 ships don't need 50,000 rounds, maybe 3,000 rounds total. At low production volumes, costs stayed high. The specialized components couldn't be sourced cheaply. There was no commercial market for GPS-guided naval artillery. Lockheed Martin quoted the real price. The Navy balked. At $800,000 per round, firing the gun costs more than a Tomahawk cruise missile. Tomahawks have longer range, bigger warheads, more flexibility. Why use the gun? The Navy couldn't justify it. LRLAP was canceled in 2016. Now the guns are deadweight, the barrels are there, the loading systems work, but there's nothing to load. The Navy explored alternatives. Could they fire standard 155mm artillery shells? Number. The AGS barrel has a unique rifling pattern optimized for LRLAP. Standard shells don't stabilize correctly. Accuracy is terrible. Range is terrible. Could they modify the gun? Technically, yes, but it would cost hundreds of millions per ship, essentially rebuilding the turrets. Not worth it. The Navy decided to remove the guns entirely and replace them with hypersonic missile launchers. That work is ongoing. It will cost over $500 million across 3 ships. So the Navy spent billions developing guns, billions building them, and now they're spending more billions removing them. This is failure compounded by failure. The integrated power system disaster. The IPS was supposed to be the future. One power generation system for everything. 2 Rolls-Royce MT-30 gas turbines, the most powerful marine gas turbines in the world. Each produces 36 megawatts of electricity. That electricity feeds the ship's propulsion motors, weapons, sensors, crew facilities, everything. The advantage? Flexibility. Redirect power as needed. If the ship isn't maneuvering fast, divert power to weapons. If you're in combat, prioritize defensive systems. Future weapons like lasers and railguns need massive electrical power. The IPS provides it. in theory. In practice, the software controlling power distribution kept failing. The system is complex. You can't just plug everything in. Power loads must be balanced. Generators must be synchronized. Distribution managed in real time. The Zumwalt uses a total ship computing environment. One integrated computer network controls everything: propulsion, weapons, sensors, power management. It's supposed to be efficient. One network, one interface, one system. Except when it crashes. On the maiden voyage in 2016, a software fault in the power management system caused the turbines to shut down. Safety protocols kicked in. The ship went dead in the water. Crew couldn't restart the system. It required a full reboot in the middle of the Panama Canal. Tugboats towed Zumwalt to port. Embarrassing, dangerous, a multi-billion-dollar warship helpless because of a software bug. This happened again in 2017. Power loss off the coast of California. Another tow. And again in 2018. Power system failure during trials. Each time, the root cause was software. The hardware worked. The turbines were fine, but the control systems couldn't handle edge cases and unexpected conditions. The Navy brought in contractors, patched the software, updated protocols. It's more stable now. But the early years revealed a fundamental problem. Complex integrated systems are fragile. A fault in one subsystem cascades through the entire ship. On a conventional destroyer, if a generator fails, you lose that generator. Other systems keep running. On Zumwalt, if the power management software fails, you lose everything. Redundancy exists. Backup systems, emergency generators. But the integrated nature of the IPS means failures are more catastrophic. The Navy learned this the hard way. Future ships will use hybrid systems, some integration, but critical systems remain independent. The Zumwalt was the test case. The lesson cost billions. The crew reduction failure. 140 crew on a 15,000-ton destroyer. That's less than half the crew of an Arleigh Burke. The Navy wanted this. Fewer sailors, lower personnel costs, more automation. So the Zumwalt was designed for minimal manning. Automated damage control, automated engineering, automated food service, even automated deck operations. Everything controlled from consoles. Fewer people needed. Until something breaks. In combat, ships take damage. Fires, flooding, system failures. You need people to respond. Damage control teams, engineers, technicians. The Zumwalt has 140 people. In a damage scenario, they're spread thin. An Arleigh Burke has 300 crew. More hands, more redundancy, more capability to respond to multiple crises simultaneously. The Navy ran simulations. In high-intensity combat where Zumwalt takes multiple hits, crew size becomes a critical vulnerability. There aren't enough people to fight fires, repair damage, and maintain combat systems all at once. Automation helps, but automation fails under combat stress. Sensors get damaged, control systems go offline. Then you need human intervention. With 140 crew, you don't have enough humans. The Navy quietly admitted this. Future designs won't pursue extreme automation. Crew sizes will be larger. But the Zumwalt is stuck with 140. Changing it now would require redesigning the entire ship. So it sails undermanned, a vulnerability that won't be fixed. The tumble-home hull. Stealth was a priority. The angular inward-sloping hull reduces radar cross-section dramatically. But it comes with trade-offs. Traditional flared hulls are more stable. The wider deck provides buoyancy. The ship resists rolling. Tumble-home hulls are narrower at the deck, less buoyancy, more prone to rolling in heavy seas. Crew reports from Zumwalt describe uncomfortable sea states. The ship rolls more than conventional destroyers. In rough weather, operations become difficult. Additionally, tumble-home hulls have reduced reserve buoyancy. If the ship takes on water, it's less stable than a conventional hull. This was known during design. The trade-off was accepted for stealth. But modern anti-ship missiles don't rely solely on radar. Infrared seekers, electro-optical guidance, home-on-jam modes. A small radar cross-section helps, but it's not decisive. The Zumwalt sacrificed seaworthiness for marginal stealth advantages. Better design, a conventional hull with radar-absorbent coatings and optimized superstructure angles. You get 80% of the stealth without compromising stability. But the Navy went all in on Tumblehome, and now 3 ships have hulls that roll too much. Another lesson learned, at great expense. What happens to the Zumwalts now? They sail, they train, they show the flag. The Navy is repurposing them for hypersonic missile testing and deployment. The plan: remove the advanced gun systems, install vertical launch tubes for conventional prompt strike hypersonic missiles. Each Zumwalt could carry 12 CPS missiles, fast, long-range, precision strike. It's a reasonable mission. The ships have the power generation for future weapons. The stealth helps in strike scenarios. But here's the reality. You don't need a $4.4 billion platform to launch hypersonic missiles. An Arleigh Burke destroyer costs $1.9 billion and can carry the same missiles. A Virginia-class submarine costs $3.2 billion and launches missiles from underwater with true stealth. Using Zumwalt for this mission is making the best of a bad situation. The ships exist. They're paid for. Might as well use them. But it's a consolation prize, not a vindication. The 3 Zumwalts will serve for 30 years. They'll conduct missions. They'll deploy. But they'll never be what they were supposed to be. A revolutionary class of destroyers that redefined naval warfare. Instead, they're expensive test beds, technology demonstrators, a cautionary tale in steel. The legacy of the Zumwalt. Future naval architects study the Zumwalt in acquisition classes. It's the textbook example of how not to develop a warship. Too much new technology, unproven systems, no fallback plan. Mission creep, changing requirements, political interference. Optimistic cost estimates, schedule delays, budget overruns. Every mistake that can be made, the Zumwalt made. And the Navy learned. The Constellation-class frigate program took a different approach. Instead of designing a new ship, the Navy selected an existing European design, the French Frem frigate. Proven technology, proven design, lower risk. The Navy is modifying it for American systems, but the core ship works. It's in service with other navies. The unknowns are minimal. Cost, $1.2 billion per ship. Reasonable. Predictable. Timeline, first ship expected 2029, slower than hoped, but realistic. This is the lesson Zumwalt taught. Don't chase perfection. Build what works. The DDG-X program, the Navy's next-generation destroyer replacing the Arleigh Burke, is also taking a conservative approach. Incremental improvements, better radar, more power, larger VLS capacity, but based on Arleigh Burke architecture. Proven hull, proven systems. Evolution, not revolution. The Zumwalt's ghost haunts these programs. Nobody wants to repeat the mistake. Final assessment. USS Zumwalt, DDG-1000. USS Michael Mansour, DDG-1001. USS Lyndon B. Johnson, DDG-1002. 3 ships, $22.5 billion. A program that promised everything and delivered disappointment. They are capable ships, advanced, powerful in some respects, but they are not what they were supposed to be, and they cost 3 times what they should have. That's the definition of failure. The Zumwalt-class destroyer is the most expensive mistake in U.S. naval history, and it will sail as a reminder for decades to come.